Welcome to this explainer. Okay, today we're going to take something that usually strikes fear into the hearts of students everywhere, dimensional analysis, and we're going to turn it into a simple, incredibly satisfying, and honestly foolproof little game. So if you've ever found yourself just staring blankly at a chemistry or physics problem, completely lost in a sea of changing measurements, well, you are exactly in the right place. Today we're breaking down a technique that literally takes all the guesswork out of the equation. All right, picture this. How do you convert 45 liters into cubic meters? Right in your head. If just hearing that question gives you a bit of a cold sweat, stick with me, because by the end of this explainer, you are going to effortlessly conquer this final boss using one ridiculously simple trick. We're going to build your skills up step by step, starting from the absolute basics, until a problem like this feels like second nature. But before we start leveling up, let's just quickly define our core concept. Dimensional analysis, at its heart, simply means we're keeping the actual physical reality, like the length or the mass, completely constant, while just changing the labels. Think about it. Whether you measure a piece of string in inches or centimeters, the actual string isn't changing its length, right? We're just changing the language we use to describe it. It's really just a translation process, nothing more. Now, the tool we use to actually change those labels, that's called the conversion factor. You can kind of think of it as the exchange rate between your units. So for example, because exactly 100 centimeters fit into a meter, the number 100 is your conversion factor when you're jumping back and forth between those two. The big secret here, it's not about memorizing endless complicated formulas. It's really just knowing your basic conversion factors and applying one very simple rule. And this setup brilliantly illustrates our playing field. I want you to literally take a mental snapshot of this layout right now. Notice how we've mapped the bigger units on the left side. So your meters, your kilometers, kilograms. And over on the right side, we've got the smaller units, centimeters, millimeters, grams. Go ahead and mentally anchor this left to right setup in your brain. Bigger on the left, smaller on the right. Got it? Okay, here is the crucial point, and honestly my absolute favorite mental shortcut. I call it the bigger/smaller trick, or just the BS trick for short. Here's the golden rule. If you're moving from a bigger unit to a smaller unit, you multiply by your conversion factor. And if you're moving from a smaller unit to a bigger unit, you divide by it. That's literally it. Multiply to go smaller, divide to go bigger. All right, level 1, basic conversions. Let's dive right in and test drive our brand new rule. We'll start with straight lines and simple measurements just to see how seamlessly this logic works. Here's your first challenge. Convert 50 inches to centimeters. Now, pause for a second and think about the physical sizes of these units. We know that 1 inch is exactly 2.54 centimeters. So using that conversion factor of 2.54, how do we actually get from our 50 inches to centimeters using our BS trick? Well, first we identify our direction. Since inches are physically larger than centimeters, inches are the bigger unit on the left, and centimeters are the smaller unit on the right. We're moving from bigger to smaller. Therefore, our golden rule says we have to multiply. We take our starting number, 50, and just multiply it by the conversion factor, 2.54. And just like that, without messing around with any confusing fractions or cross-canceling, we get exactly 127 centimeters. The logic holds up perfectly. Because we're chopping that length into smaller pieces, the centimeters, we obviously need a larger quantity of them, which is exactly why multiplying makes total sense. Okay, now let's flip the script. Let's try going the other way around. What if we start with 50 centimeters, and we want to find out how many inches that is? Let's consult the rulebook. This time around, our starting point is centimeters, the smaller unit, and our destination is inches, the bigger unit. Because we're now moving from the smaller unit to the bigger unit, the BS trick tells us we have to divide. We simply take our 50 and divide it by our conversion factor of 2.54, which gives us a nice, clean 19.68 inches, completing level 1. And hey, notice how we didn't have to change the conversion factor itself at all? The number 2.54 stayed exactly the same. The only thing we changed was whether we multiplied or divided based entirely on our bigger to smaller direction. Moving right along to level 2, stepping up. Let's see how this builds when we start combining moves for some medium-level questions. Because, you know, in the real world, you rarely get to jump straight from point A to point B. Sometimes you need a stepping stone. Take a look at this one. Convert 8,000 millimeters to kilometers. So how on earth do we jump all the way from tiny little millimeters to massive kilometers, especially when we generally only know their relationships to the standard middle ground meter? Well, the secret is you don't do it all at once. We just take it in two simple steps, treating the standard meter as our bridge. First, we go from millimeters to meters. That's smaller to bigger, so we use our divide rule. Dividing 8,000 by 1,000 leaves us with 8 meters. Step 2, we go from meters to kilometers. Again, that's smaller to bigger. So we divide our 8 meters by 1,000 to seamlessly arrive at 0.008 kilometers. Boom, done. All right, things are heating up. Level 3, cubed units. Now this right here is where most students completely freeze up, or they make critical errors by trying to use standard linear conversion factors for three-dimensional problems. Dealing with volume, meaning 3D space, and converting 1 cubic meter into cubic centimeters sounds incredibly intimidating, right? I mean, you might be tempted to just multiply by 100 because, hey, there are 100 centimeters in a meter. But remember, we are dealing with cubes now, not straight lines. The super easy trick I personally use here is to just write down the basic linear unit relationship first. So write it out. 1 meter equals 100 centimeters. And then to make it dimensional, you quite literally cube both sides of that entire equation. Let's look at the math on that. The 1 cubed just stays a 1, and the meter becomes cubic meters. But on the other side, the 100 cubed becomes 1 million. That's a 1 with 6 zeros. And the centimeters become cubic centimeters. This gives us our massive new volume conversion factor of 10 to the power of 6. So to convert from a bigger cubic meter to smaller cubic centimeters, we simply multiply by 1 million. And here we are, boss level literatis. We've leveled up enough, so it is officially time to mix volume measurements with standard capacity measurements. This takes everything we've learned so far. First, to figure out how many liters fit into a cubic meter, we need a common stepping stone. We just learned that 1 cubic meter equals 1 million cubic centimeters. Now here's a crucial fact. There are 1,000 cubic centimeters in a single liter. Because the cubic centimeter is tiny and the liter is the bigger unit here, we apply our smaller to bigger rule. We take our 1 million cubic centimeters and divide it by our conversion factor of 1,000. And that calculation gives us the beautiful realization that exactly 1,000 liters fit perfectly inside one single cubic meter. Try to think about that visually for a second. A box that's 1 meter wide, 1 meter deep, and 1 meter tall holds exactly 1,000 liters of water. Now, we have our ultimate boss level conversion factor, 1,000. So, returning to that opening challenge that might have given you cold sweats earlier, converting 45 liters into cubic meters, we now know the conversion factor between liters and cubic meters is 1,000. A liter is the smaller unit, and a cubic meter is the much bigger unit. So we simply apply the smaller to bigger rule, and we divide our 45 liters by 1,000. And the final answer is 0.045 cubic meters. No panic, no second guessing, just pure structured logic. By simply identifying the conversion factor and asking yourself if you're moving bigger to smaller or smaller to bigger, you basically have a master key for almost any scientific math problem out there. So, now that you've mastered the incredibly simple logic of dimensional analysis, what conversion are you going to effortlessly tackle next?